This is the network attacks video. Network attacks are deliberate actions that target computer networks with the intention of gaining unauthorized access, disrupting operations, or stealing information. The majority of these network attacks are denial of service in nature and intend to overwhelm victim systems. Network attacks can take other various forms, though, including phishing or network intrusion attempts. Let's first look at a DOS attack. This is a denial of service attack. These attacks aim to deny access to network services and typically originate from a single source, such as a compromised computer, for the purpose of exhausting victims' resources and crashing the system. A DOS attack is a malicious attempt to disrupt the normal functioning of a system or network by overwhelming it with a flood of illegitimate requests or excessive traffic. A DOS attack begins with a malicious actor using a tool to send a large number of packets to a victim device to overwhelm it. These victim devices attempt to process all of these packets and exhaust their resources, causing the system to crash. These types of attacks don't stop there. Malicious actors have found a way to amplify these attacks to make them more dangerous, such as a distributed denial of service attack. DDoS attacks are a more sophisticated form of DOS attack that involves multiple systems collectively attacking a target. DDoS attacks utilize a network of compromised computers known as a botnet, which are under the control of the attacker for the purpose of multiplying the number of malicious packets going to be sent to the victim. The DDoS attack begins with the malicious actor infecting each bot with malicious software. This allows the malicious actor to create a command and control or C2 connection to issue commands to each of the bots. Once those commands are issued, each bot will send a large number of packets to the victim, quickly overwhelming the resources and crashing the server. The next attack is a DDoS reflected attack. DDoS reflected attacks utilize an IP spoofing technique to redirect responses to victims. In this attack, the attacker spoofs the source IP address and sends a series of pings to the bot computers. For each ping packet sent, there are 4 ICMP replies to the ping. Without the use of the spoofing technique, the attacker would receive all of those ping responses and in essence be attacking themselves. With the spoofing technique, the source IP address of the packet is not the actual original attacker, but the victim's IP address. So the responses would then be redirected to the victim, crashing that victim. The next attack is a DNS domain name system amplification attack. In this type of distributed denial of service attack, the attacker exploits the characteristics of the DNS protocol to amplify the volume of traffic directed at a target. The attacker identifies a DNS server that is misconfigured or has an open resolver configuration. These servers accept DNS queries from any source IP address and respond with the requested information. The attacker spoofs the IP address of the victim and sends DNS queries, making it appear as if they originated from the victim's IP address. The types of small queries sent to the DNS server are designed to generate a large number of data responses from the server to the victim. This is another example of amplification of network traffic for the purpose of crashing the system. The next attack is an on-path, sometimes called man-in-the-middle attack. An on-path attack is the type of attack where an attacker positions themselves in the communication path between two parties, thus intercepting and potentially altering the communication between them. Attackers attempt to guess the client's session token for the connection. If they are successful, they can execute an on-path attack. For example, in this scenario, the attacker intercepts a packet from the legitimate client. They can either just view the information or modify it and send it on to the legitimate server. When the server replies, the packet goes to the attacker first, and then they just relay it to the legitimate client. In essence, the attacker impersonates the server to the client and the client to the server. The next attack is a credential replay attack. A credential replay attack, also known as a replay attack, is the type of attack where the attacker intercepts and reuses the captured credentials or authentication token to gain unauthorized access to a system or service. In this attack, the attacker does not need to crack or decrypt the credentials. Instead, they simply replay the captured credentials to trick the system into granting them access. It begins with the attacker intercepting credentials from the client. The attacker then forwards the credentials to the server, and then the server grants access to the attacker. The next attack is a DNS cache poisoning attack. DNS cache poisoning involves corrupting the data stored in DNS caches to redirect legitimate traffic to malicious websites or servers. The attack begins with an attacker sending bogus DNS replies to the DNS server to corrupt the cache. This is followed by a client querying the DNS server for www.google.com, but instead of the client connecting to Google, they are redirected to a malicious server. The next attack is a cross-site scripting attack. A cross-site scripting attack is a web application vulnerability that allows attackers to inject malicious scripts into web pages viewed by other users. This occurs when the web application does not properly validate or sanitize the user-supplied input, allowing the injection of malicious code that is then executed by the victim's browser. The attack begins with a malicious actor injecting malicious JavaScript into a web page area through an input form. Then an innocent user logs in and accesses the infected area. Then the malicious JavaScript is downloaded and executed in the user's browser. Next, the user's browser sends the session token to the attacker. The attacker can then use the user's token to hijack the user's session. The final attack is a cross-site request forgery attack. Cross-site request forgery is a type of malicious attack that tricks authenticated users into performing unwanted actions on web applications without their knowledge or consent. Cross-site request forgery attacks exploit the trust between a user's browser and a target website to make unauthorized requests on behalf of the user. This attack begins with a user logging into a bank website. The bank website delivers a session token to the user. The attacker sends a malicious link that appears to be from a trusted location, most likely the website, and tricks the user into using it. The user clicks the link and it allows the attacker to use the original user's token. This allows the attacker to withdraw funds and execute other malicious activities. The primary goal of network attacks is to exploit weaknesses in network defenses and compromise the confidentiality, availability, or integrity of network resources. With our ongoing commitment to improving our course, we ask that you leave a review stating what you liked about the course and what you felt could be improved. There are 3 places you can go to leave a review while accessing your course on a laptop or desktop. From the course cards in your My Learning page, in the course player from clicking on Leave a Rating, and within the course prompt. While viewing the course, you'll be prompted to leave a review 3 times, at the beginning, the middle, and the end of the course. All of these reviews will be visible to the instructor and other students, but if you update your review, only your latest changes will be visible. That completes this network attacks video.